Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video I am going to discuss one numerical which is related to concepts of rectilinear motion or if any particle is following a straight line path. So let's start the numerical which is related to rectilinear motion, and the numerical is here. The numerical is given: a particle move with uniform acceleration along a straight line ABC. The speed of the particle at position A and C is given 10 cm per second and 50 cm per second respectively. If the point B lies in the midway between A and C, what will be the ratio of time taken by the particle to travel distance AB and BC? So in this particular numerical, the thing which are given, here we are considering a particle which is moving with uniform acceleration along a straight line ABC. So let's draw the straight line ABC. So this is our straight line path and this is represented by ABC. So the first part we are considering as AB and the second part we are considering as BC. So the speed of the particle at position A and C is given. So the speed is given at point A. If we are considering this as VA and VC, so the value of VA and VC is given. VA is given 10 cm per second and VC is given 50 cm per second as per this numerical. If the point B lies in the midway between A and C, here if we are considering the total distance between A and C is L, so this B is the midpoint of this AC path and this point B is situated at L by 2 distance from the point A. Similarly, L by 2 distance from point C. So this B point is representing the midpoint of path A, B and C or between A, C. So here let's read the numerical. The next point: what will be the ratio of time taken by the particle to travel distance AB and BC? Here if we are considering the time taken by the particle to travel the distance AB and BC is different because the velocity at this particular initial point and the final point is at this particular initial point and the final point is different. So the time taken by the particle to travel the distance AB and BC should be different. So here if we are considering T1 as the time taken by the particle to travel the distance AB and the time T2 is taken by the particle to travel the distance BC. So we have to find out the ratio of time taken by the particle. So T1 by T2 we have to find out. So let's start the solution here. So here we are considering T1. So this T1 is represented by the time taken by the particle to travel the distance L by 2 between A and B, and T2 we are considering as the time taken by the particle to travel the distance L by 2 between B and C. Now here we are considering VA is the velocity at point A for the particle, VC is the final velocity for the particle at point C. Now at point B, if we are considering the velocity of particle is V, so we will use the equation and we will use VA, VV and VC term for the velocity. Here we are considering the straight line motion or the rectilinear motion, so we will apply different equations which is related to motion. And here the particle is traveling from A to C and it is following the trajectory is straight line. So we can use the equation of motion here, and the equation which we are using, that is, so this is our equation: v square minus u square equals to 2as. Now here if we are considering 2 points A and C, A is our initial point and C is the final point. So the initial velocity we are considering as VA, so VA will be equals to u and Vc will be equals to V, because this is the initial velocity and this is the final velocity. So this will be our equation in terms of final velocity and initial velocity. So it will be Vc square minus V square equals to 2AL. Now we have the values of Va and Vc. Vc is 50 centimeter per second and Va is given 10 centimeter per second. So we will put these values here. So this will be our equation if we are putting the value of Vc and Va in this particular equation. So it will be 50 square minus 10 square equals to 2AL, and A is representing as the uniform acceleration. A is representing the uniform acceleration. So with the help of this particular equation, we can find out the value of A in terms of L, because L is also unknown. So this particular equation we will consider as equation 1. Now here, let's take the another velocity Vb. Here let us consider this particular path A and B. And for this A and B, we are applying the same formula. When the particle is traveling from point A to point B, so the final velocity we will consider as Vb and the initial velocity we will consider as Va. So if we apply the equation of motion for this, so we have this particular equation for path AB and we will solve this equation, and here we know the value of VA and this L and L will be cancelled, so we can find out the velocity at point B. So the final value of VB will be 41.9 centimeter per second. Now here we have the third velocity also, so we have all the values VA, VB and VC. So we will consider here the time taken by the particle to travel the distance AB and to travel the distance BC, and we will find out this particular time with the help of velocities. So let's find out. So if we want to find out the time taken by the particle to travel the distance AB or the L/2 distance, so this T1 we can find out by the equation V minus U by A. So here if we are considering AB path, so it will be VB minus VA by A. So we will put all these values here. So this equation will be 41.9 minus 10 divided by A. So A is the unknown value, so we will keep it this particular value of A as it is, and let's find out the value of T2. So as per the same concept, V minus U by A, that is equals to time, we can find out the value of T2. So this T2 we are considering the time taken by the particle to travel the distance BC. So it will be VC minus VB by A. So we will put the value of VC and VB here. So here we have these two equations of T1 and T2. Now what we have to find out? We have to find out the ratio of time T1 and T2. So T1 by T2 will be, the T1 is 41.9 minus 10 by A and it is divided by 50 minus 41.9 by A. So this A and A will be cancelled out. So this is our final term, 31.9 by 8.1. So it will be 3.9 seconds and it is nearly equivalent to 4 seconds. So the ratio of T1 and T2, or we can say the time taken by the particle to travel the distance AB divided by the time taken by the particle to travel the distance BC will be 4 seconds. So this is the solution. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.